In this video, I briefly want to talk about something called trigonometric identities. Let me start by explaining what an identity is, since I think we already know what trigonometric means. An identity is an equation which is true for all values of the variable. So, the equation true for all values of the variable. For example, let me give you an identity that has nothing to do with trigonometry. Let's say I give you something like 2 times x plus 1 equals 2x plus 2. I don't care what x is. The left side of this equation is equal to the right side of this equation. If we try to solve this equation, so we get 2x plus 2 equals 2x plus 2, or 0 equals 0. That's true no matter what x is. And you can check. If x is, say, 3, the left side of this equation is 2 times 3 plus 1, which is 2 times 4, which is 8. And the right side of the equation is 2 times 3 plus 2. That's 6 plus 2 is 8. Left side is equal to the right side. It doesn't matter what x is, the left side is going to be equal to the right side. You can see that based on your very, the easiest kind of algebra that you know. You can see that the left side is going to be equal to the right side. So trigonometric identities are identities that involve trigonometric functions that are true for all values of the variable. Let me start with the first and perhaps most important trig identity, the Pythagorean identity. The Pythagorean identity says that sine squared theta plus cos squared theta, I don't know if that's visible, equals 1. No matter what angle theta is, if you take sine of it and square that, and then you take the cosine of it and square that, and you add them all up, you're going to get 1. If you're wondering why this is called the Pythagorean identity, it's because it's just the Pythagorean theorem in disguise. Let me draw a right angle triangle for you. I'll call this angle right here theta, the measure of that angle theta. And we know that relative to theta we have an opposite side, we have an adjacent side, and we have what we call the hypotenuse. And we know that sine of theta is the opposite over the hypotenuse, and the adjacent side, the cosine of theta is the adjacent side over the hypotenuse. So let me go ahead and take a look at the left side of this equation. Sine of theta all squared is the opposite side over the hypotenuse all squared. That's sine of theta all squared. Cosine of theta all squared. Cosine of theta is the adjacent side over the hypotenuse, all squared. Let's just work this out. So we know that a power distributes over division, so this is just the opposite side squared over the hypotenuse squared. And this is just the adjacent side, the measure of the adjacent side divided by the hypotenuse squared. Adjacent side squared over the hypotenuse squared. And when I say the opposite side, I just mean the length of the opposite side. When I say the adjacent side, I just mean the length of the adjacent side. And when I say the hypotenuse, I just mean the length of the hypotenuse. These are just measures of those sides. It's easy to add two fractions when they already have the same denominator. You just write the denominator down. So that's the hypotenuse squared. And we just add up the numerators, the opposite squared plus the adjacent squared. But this is a right angle triangle. If you take this squared and you take that squared and you add them up by the Pythagorean theorem, a squared plus b squared equals c squared, you get that squared. So opposite squared plus adjacent squared is just the hypotenuse squared. And it's over the hypotenuse squared. And so that equals 1. Anything over itself equals 1. So yeah, the sine squared plus the cos squared, this plus this squared plus this squared, equals 1. It's just the Pythagorean theorem in disguise. We use the Pythagorean theorem going through this equal sign. So this is probably the trigonometric identity that's going to come up most often in your future. Let me list 2 more trigonometric identities, well, technically 4, right now, that will be coming up at the beginning of a calculus class. One is the sine sum and difference formula. So let's say I have sine of, instead of using Greek letters, I'm just going to use Roman letters. So sine x plus y. If you would prefer to write alpha plus beta or theta plus gamma or whatever, feel free. But sine of x plus y is equal to sine x times cosine y plus cos x times sine y. And if you replace that plus sign with a minus sign, just replace this plus sign with a minus sign. And if we have the cosine sum and difference angles, the sum and difference identities, we have sort of 2 more formulae. Cosine of x plus y equals cos x times cos y minus, this time with the plus goes a minus, sine x sine y. And if you replace this plus sign with a minus sign, you replace this minus sign with a plus sign. There are many, many more trig identities. Each one can be proven. These 2 have very nice slick proofs, just drawing a rectangle. If you're curious, just look up the sine summation formula on Wikipedia, and they'll give you a really nice little picture that basically proves the whole thing in one little block. It's very slick. And you can prove the cosine sum and difference formulas. From the sine and cosine summation formulas, you can prove what are called the double angle formulas. You can prove what are called the half angle formulas. Trigonometry is replete with these identities. But I think starting with just these will be plenty for now, and you can add more later when you need them.